You are given a sorted array called nums in ascending order. The task is to convert this array into a height balanced binary search tree. A height balanced binary search tree is a binary tree where the depth of the two subtrees of every node never differs by more than one. Okay, what could be our approach? This problem is classic application. It's a classic application of like a divide and conquer. Like the middle element. Like if you can think about it, like you can feel like divide and conquer. So you find always the middle element of the array becomes the root of the tree. Like always, the middle element will become the root of the tree, ensuring that the tree remains balanced. The left half of the array becomes the left subtree, and the right half becomes the right subtree. This one, the right half. How we can solve this one? We can do like a recursive function that will take an array of nums and we'll just try to call them each one for each node, because the tough thing is to find where is the children and where is the parents. But I guess this is not that tough, to be honest. Okay, how we can solve this? We can solve this by calling this function on the left side and also on the right side. We need to find the middle as well. How we can do that? So it's a recursive function. That means it's a function that will call itself over and over and over. So what we will do before we doing anything in the recursive function, we find a base case. So I would say if nums dot length equals 0, we need to return null. And I would say const mid will equals math dot floor, and we have here nums dot length will be divided by 2, because we need to and this will be the middle. We need to find the middle index. After that, we need to create the root node with the middle element, because it's pretty important to create a root. For each tree, it has a root. So const root will equals new tree node. As you can see here, there's something called tree node. New tree node, and let's look at it. We need to have a value and left and right. Okay, but I guess we will add value for now. There is no left and there is no right. So I would say the value will be nums dot of mid, the index of mid. Okay, so then we need to recursively build the left and the right subtrees. So we do root dot left will equals I will call this again, and I will put I guess right now we need to put the left half of the array. Okay, so how we can do this one? We can do like nums dot slice, and it will be from 0 to mid, and we need to make the right half, and the right half, it will be from mid to from mid plus 1 to the end. So we need only to do mid plus 1, and after that we return the root. Okay, it's a recursive function, as we said before, so it's not that easy to understand. So let's just try to understand it one by one. In the first, we have a base case. Always in any recursive function problem, we should have a base case. Like if the array is empty, like nums.length equals 0, we return null. After that, we have the recursive case. Like we find the middle element of the array. Mid equals, which here, mid should equals math.floor nums.length divided by 2. After that, we need to create a new tree node with the middle element as the root. After that, we recursively call the function on the left half of the array to build the left subtree. and we recursively call the function on the right half of the array to build the right subtree. And when we do that, we just create a new root, and the root would be for root something like that. It will be it's basically a recursive function problem. To understand, you need to find an example. So how we can do that? Let's just find an example. Before everything, let me run and make sure that the code is working good. Okay, the code is working good. Okay, let's follow an example to understand how the code will work. So let's assume that we will have an input, and let me just put the input for you guys. So this will be our input, okay? And right now the middle element will be here, number 0. So it will be sorry. So it will be, I guess, index of 2. So since the middle element of 0, the root will be equal to 0, okay? And after that, we will do the left subtree, and this will be the left subtree. And after that, we basically call the left subtree again on this element, and we try to find the middle, and we do it over and over. And the and here in the middle element, I guess in the left subtree, I guess it will be -3. And the left child of it will be the left child of root. And after that, we have another left subtree, which will be -1. Here we -10, sorry, and the middle and yeah, this is the only left to it, so we just add to -3. And so right now, let's try to understand how how it works. So 0, and we have like no like okay, I'm not good at trying taking trees on code, so I'll just try to redone the thing. So okay, if you looked at it, you find that we have 0, and we call the function again on the left side. So we call the function, and we just find the middle with equals -3. So we add it, and we have the list -10, so we add it again. And on the right side, we has 5 and 9. We find the middle element, and the middle element equals 9, which is the right child of root. After that, we have a left subtree, which called 5, or it's 5, which is a leaf node. And yeah, I guess it's not that easy to describe any recursive problem, but yeah, it is how it is. So that's it for this problem, and I hope you like my content.